Hi guys, this is another video which is dedicated or linked with using vectors in solving numericals of physics. How to add or find resultant of two vectors. Now there can be numerous vector physical quantities which you would encounter in day-to-day physics activities and while solving physics numericals, such as forces, electric field, magnetic field, momentum, etc. So how to add two forces, how to add two momentums, how to add two electric fields. So if you are dealing with such type of problems, then this result is going to teach you how to solve or get a resultant, find the sum of two vector quantities. This result, I am using the symbol R to indicate the resultant, and R is equals to under the root of first vector square, this means the magnitude of first vector square, plus magnitude of second vector square, plus 2 magnitude of first vector multiplied by the magnitude of second vector into cos theta, where theta is the angle between the two vector. It happens to be the angle between the two vectors. Now this result is going to be quite useful if you have got to find resultant of any two vectors quantity. Now here one should remember I am using just the magnitude. V1 is this vector while V2 happens to be this vector, and this happens to be the angle between them. The resultant will always be directed in between the two vectors. So resultant will be directed in between the two vectors. The direction of vectors can be the direction of the resultant vector, if I denote by some angle alpha, can be found by using a formula tan alpha is equals to V2 sin alpha upon V1 plus V2 cos alpha. V2 sin theta upon V1 plus V2 cos theta. Please just overlook that alpha what I said. The resultant would make an angle of alpha with the first vector V1, and that angle can be found by using formula tan alpha is equals to V2 sin theta upon V1 plus V2 cos theta. Now few corollaries. To the above result. If theta is equals to 0 degree, that means both the vectors V1 and V2 happens to lie along the same direction, then probably you would not use the entire result. I am just simplified that result. You can find the resultant simply by adding the magnitude of the two vector, that is R is equals to V1 plus V2. If theta happens to be 180 degree, then simply what you have to do, you have to simply subtract the magnitudes of the two vector. So our resultant vector will be V1 difference V2, and if theta happens to be 90 degree, that means the two vectors are perpendicular to each other, V1 and V2, and this angle happens to be 90 degree, then the resultant can be used or find out very easily by the formula R is equals to under the root of V1 square plus V2 square. All these results have been obtained by putting the value of theta in the above equation. Above equation means this equation number A. So in this equation I have put out the values of theta, and I am just generalizing the result. Now if theta happens to be 60 degree, then in that situation the resultant would be under the root of v1 square plus v2 square plus v1 v2, because cos 60 degree is half, so will give me v1 v2. And if theta happens to be 120 degree, then the resultant can be found out using the formula v1 square plus v2 square minus v1 v2, because cos 120 degree happens to be minus half. So note down these results, they are going to be of importance to you. Another very important aspect, if you find the two vectors to be of equal magnitude, if v1 happens to be equal to v2 in magnitude, then the resultant would always, resultant vector would always lie along the angular bisector. Now this result is of very much importance when you are going to deal the numerical problem. So if you are finding this as the first vector v1 equal in magnitude as v, this being the second vector v2 also equal in magnitude as v, the angle between them is theta, then the resultant vector r would happen to lie at an angle bisector. So this will be theta by 2, this will be theta by 2, this will be equal to alpha. So if you know these results, you would find your numerical solving approach to become much more easier.